Hi everybody, it's Miss Dolly. I'm ready for video number 2 and to assign homework number 2. So, I just put this on a blank page somewhere. You don't have a number on this page, but it's after page 4. I will put this in the Google Classroom. The notes today will be on, the video notes will be on page 14 and page 16. I'm adding a couple problems to one of those pages too, to do some extra work on that. And I'm adding a couple of problems to your homework page, which is 15, 17, 18. This is your homework page. And from the SATs, 39 and 40. There's one problem on the SAT you don't need to do because it doesn't relate to this material. So again, your video is 14 and 16. Your homework is 15, 17, 18, 39, and 40 with whatever I add to it. Okay, so I know you've been getting some answer keys, but you don't have all the answers. I'll try to do that either by the end of the summer or on the first day of school. I do want you to concentrate on the fact that the integers was one of the biggies for us, like a very, very important thing. And I'll check those off for you because there is something where integers are important today. So an integer is like the number 5, -7, the square root of 16 is 4, so that's an integer. 0, 44, -1, I can't read that because the numbers are so small, it looks like -10,000. So integers is the big one because a lot of times SAT questions say, give the answer that's the integer answer or the integral answer. The other one I wanted to show you is, if some of you did your homework, well, you must have done your homework, so it's not an if, it's that you did your homework on this and you isolated the variables. When you went to isolate the variables, you got these were the only answers provided for you. You could do this as a screenshot right now and zoom in on your screenshot and then take a look, because there is an alternate answer to isolating the C that's acceptable. Instead of 5/9 times F minus 32 in parentheses, you could have distributed the 5/9. So take a screenshot of all these possible answers over here and take a look if yours was wrong and you want to know if it's right. Another thing that happens is if you're giving an answer to something like y equals 2/3 x plus 4, that's a good answer. Another way to write it is remembering that the x on the side is really like on top. This is another way to write it. I mean, the slope-intercept form is preferable where the x is on the side. It could be on top over here. However, this is just if an answer came about. The x in the denominator is different from the x on top. The x in the denominator is different from the x on the side. So just letting you know, this x down here on the same level as the 3, if you can see that, is the same as if you put the bar here also. So if you put the bar here with the x on the bottom, it's the same as the x as small as that 3 also. So if you're going to put the x with nothing, you kind of need to make it like a little bigger to show, and not, if this is the line, see the x is not touching that line. It's a big deal to not let the x touch that line. Okay, moving along for now, the notes we're going to take. So we're going to start taking notes on page 14. So there's only 2 types of equations I want you to know. There's many types of equations, but the 2 types of equations I want you to know: slope-intercept form and standard form. So the slope-intercept form looks like this: y equals mx plus b. It's when the y is isolated and the m stands for the slope and the b stands for the y-intercept, where it intersects the y-axis. So the slope-intercept form is y equals mx plus b, and the coefficient in front of the x comes first, that's the slope, and then you add the b. And the standard form of the line is manipulating that to unisolate the y, and it will look like this: ax plus by equals c. But here's that kicker word that's very important. A and b and c are integers. And if they're not integers, it's not in standard form. Standard form means that the a The x and the y have to be on the left-hand side with their proper coefficients, and the c, or just whatever number that doesn't have the coefficient of x and y, have to be on the other side. But the a, the b, and the c has to be integers. Or you can say integral coefficients. There's that key word. It comes up all throughout the year. Okay, so let's do example 1 together. It's on page 14, and I wrote something in for you because I want you to understand that it could be written in a different way, but I can't give you like all 8 ways that it could be shown. So I really think that you need to understand this as a review for algebra. When they say I want all the forms, I basically want these 2 forms, the slope-intercept form and the standard form. Slope-intercept form and the standard form. So I'm going to start with the slope-intercept form of the line while I'm given 2 points that the line goes through. So you're going to create this equation that looks like y equals 3x plus 4, y equals 4x plus 5, y equals 2/3 x. It doesn't matter if it's a fraction or not. Just to let you know, you're getting these 2 points, negative 2, 5, and 3, 1. That means if you were to graph this line, it would go through negative 2, 5, which maybe it'd be up here, and then 3, 1, and this is what the line would look like. Now you're going to give the equation of it, but do you see how it tilts to the left? That means it's going to be in, is it 3? It's going to be in negative slope. It's tilting to the left, but we're going to figure out that slope soon. Just to show you other ways it might be presented, especially in SATs, they might actually put this in a table, negative 2, 5, 3, 1 in a table like this, or a table like this going horizontally. So that's just an FYI, and they might put another point, or they might say, you give another point that's on that table. And once you have the equation, you can give another point. That's actually going to be an SAT question. So let's start with the slope. The way you find the slope is you do the change in the y over the change in the x. That means you just subtract the x's on top, the y's on top, and the x's on the bottom. But when you do that, you need to keep the same direction. So if I'm going to subtract that way to the left, and I'm going to do 1 minus 5, that's fine, as long as I do 3 take away, negative 2 on the bottom, same direction. So that gives me negative 4 over 5, which is going to be my slope. So when I go write this equation, I already know it's going to be y equals negative 4/5 x. And then plus something or minus something. My guess is going to be plus something because if you can see it over here, it's going through the y-intercept in a positive place. Now all I have to do is pick a point that is on that line and use it to substitute it into y equals negative 4/5 x plus the b. The b is the y-intercept. That's what I'm solving for. So you pick the easier of the 2 points. I think 3, 1 is easy because it has a 1 in it and there's no negatives. So the x is the 3 and the y is the 1. So you do y equals negative 4/5 times 3 plus b. You're using a 4-function calculator here, so you're going to need to know your fractions a bit. So negative 4/5 times 3 is negative 12/5. I'm now going to add 12/5 to both sides. And that's 5/5 plus 12/5 is 17/5. So the b is equal to 17/5. So that's going to be part of my answer over here. So my answer in slope-intercept form is y equals negative 4/5 x plus 17/5. Now the thing is you're going to want to do, I wish I had another piece of paper. Let me think. I could just use the back of this. You're going to want to put this in standard form. So I'm going to write it a little bigger on a blank piece of paper. So if you have y equals negative 4/5 x plus 17/5, and you want it in standard form, remember, this needs to go to the other side. So you're going to add, and it doesn't combine with the y, right? So you're just going to write it as, you can write 1y. So you write 4/5 x plus 1y equals 17/5. So everybody's in the right position. The problem is these need to be integers, integers, integers. So this one is already an integer, but I can't say you don't have to worry about it, because what you need to do is multiply through by 5 to make everybody an integer. So I'll multiply him this side by 5 and that side by 5, and then I'll distribute. and then the 5's cancel, and I get 4x, and then plus 5y, and then equals 17, because those 5's cancel. So the standard form is 4x plus 5y equals 17. So you've got the slope-intercept form, and you've got the standard form. There is another form, but it's not something that we talk about. It's called point-slope form. It's not something we use often in our class. So, by the way, if it wasn't a table form and they said, hey, can you give me another point that lies on that line? I mean, you could make one up and say, I'm going to plug in a 10 and see what pops out. But that's more of an SAT question, so I'll show you that soon. All right, and in this one, we already have the slope, so we're very lucky, and we can start writing our equation as y equals 1/3 x plus b, and all we have to do is find out what the b is by plugging the 1 in for y, the 2 in for x, and we get 1 equals 2/3 plus b. We subtract 2/3 from both sides, and now we have our b, which is 1/3. So our equation is y equals 1/3, nope, 2/3, right? 2/3 x on the side like that, not touching the bottom, otherwise I think it's in the denominator. Not touching this line, otherwise I think it's in the denominator, plus 1/3. Now, I could get the standard, and I'll do that in a second, but if this were an SAT question, they'd go a little further, and they'd say, as a follow-up question, if you can zoom in on this and then, write it out, it says, circle another point on this line. So instead of graphing this line, you could graph this line. You could say, I have a 2 and a 1 here, 2, 1, and then I go up 1 and over 3, up 1 and over 3. And you can imagine which of these points is on the line. One of the things you could do is you could plug all these points in and see which works. So you could say, I'm going to plug in 0, 3. So my equation is y equals 2/3 x plus 1/3. I can plug in the 2/3 times 0 plus 1/3 and ask myself, does it equal 3? It doesn't, so that doesn't work. You could say I could do 4 equals 2/3 times 11 plus 1/3, and that would be 4 equals 22/3 plus 1/3. And I'm not sure I thought that one was going to be the one that works. And it's 4 is equal to 23 over 3, so that one doesn't work. As a matter of fact, none of these work. I thought I made one up that works. So none of these points are on this line, but maybe it is. Maybe I'll try the 1. 1 equals 2/3. No. So we'll do this. Maybe there is one that works. 1 equals 2/3 times 3 plus 1/3. So it's 1 equals 2 plus 1/3. Nope, that point doesn't work. So let's try this one. 3 equals 2/3 times 1 plus 3. And guess what? That one doesn't work either. So it's none of these points work. I thought I made one up that works, but none of these points are on that line. But when you do it on the SAT, at least you'll know which one plugs in. If there's anything that I write too fast, all you have to do is freeze your frame while you're taking notes. If I wanted to put this in standard form, remember what you would do for standard form. You bring the 2/3 to the other side, right? And then you say, oh, I think I'll multiply everybody by 3. So you get negative 2x plus 3y equals 1. That doesn't look like standard form on that one. Oh, it's a 1/3. 2/3. Oh, everybody hi. Oh, I know what I did wrong. That's a 1/3 right there. So I bet one of these points work. I think it was this one that works. So sorry about the mistake. Just to let you know, it is 7:30 in the morning. That's probably why I'm making my mistakes. So I'm going to bring this 1 back to the other side. And then this, I believe, is your standard form of this equation. So you could have negative 1x plus 3y equals 1. Or it could have been 1x minus 3y equals negative 1. That's the standard form. By the way, I think of all of these that work, I think the 11-4 did work. So I'm just going to try it again for you. And now that I have the right equation in, everybody, sorry about that. So let me plug in the 4 equals here. And then the 1/3 times the 11 plus the 1/3. I think it's going to work. So 4 equals 11 thirds plus 1 third. So 4 equals 12 thirds. Check. This is another point that works. The reason I threw that in is it's a very SAT-like question. So a teacher can teach you all about how to do slope-intercept form, how to do standard form, but the SAT takes it one extra step. And the one extra step that the SAT takes it is, hey, after you give me the equation, can you give me another point over here, or circle the right point, or can you give me another point? By the way, the other thing that the SAT does is they give it to you in different forms than here's the ordered pair. They might put it in a table vertically or horizontally. So I just did those two for you. Okay, the next two questions look like this, and it talks about parallel and perpendicular. I'm going to do this one first because this one's actually the easier of the two. And when I say lines are parallel, as you know, in geometry, when lines are parallel, they look like this, or, they never intersect. But in algebra, when lines are parallel, we say they have the same slope. But algebra and geometry overlap, so that's a good thing to keep them both in perspective. So whatever I do to write this equation of a line passing through 36, negative 48, and parallel to this, I'm going to want it to have the same slope as this. So what I need to do to get the same slope is I have to find out what this guy's slope is. So I do that by isolating the equation, isolating the y, and so I'll start with negative 3y equals negative 4x minus 20. Then I'll divide by negative 3, and I will get y equals 4 thirds x plus 20 over 3. Now, I do not need the 20 over 3 because it didn't say anything about having the same y-intercept. It said something about being parallel lines, so therefore the slopes are same. So the slope I'm going to use for this equation is 4 thirds. So I will now take the 4 thirds and start saying I am going to have an equation with 4 thirds in it and some y-intercept. It goes through the point 36, negative 48, so I'm going to plug those points in for the x and the y. And for function calculators, not too hard on this, you should know how to do 4 thirds of 36. 4 thirds of 36 is 48. And then you subtract, or get used to using your function calculator for that. And then b is equal to negative 96. So my slope-intercept form of the equation is y equals 4 thirds x minus 96. I might not be able to fit that in here, so I'm going to put it right here. Y equals 4 thirds x minus 96. So now, if I want the standard form, I'm going to bring the 4 thirds to this side. And I'm going to say, oh, I needed a coefficient that's an integer. So I can multiply by 3 on both sides. You can multiply by negative 3 if you want also, as long as you get rid of the 3 all the way through. So the 3 on this side and the 3 on this side. So now I have negative 4x plus 3y is equal to, is that minus 96? Negative 288. So you can have negative 4x plus 3y equals negative 288. It could have also been 4x minus 3y equals 288. Now, if I'm going to do the same, if this example 4 is a lot like example 3, except answer 3 wants a perpendicular slope. Perpendicular lines, they're perpendicular lines, which means their slopes are opposite and reciprocal. If you remember that, opposite reciprocals. I did that in also Algebra 1, in my Algebra 1 academic level. So the opposite reciprocal to the 4 over 3 would be the negative 3 over the 4. So that is what I'm going to use as my reciprocal slope. So, oops, let me edit the form here. So I'm going to start like this. Y equals, so we said the slope was 4 thirds. Now it's going to be negative 3 fourths, and then x plus b. And then I'm going to plug in my points. Negative 48 equals negative 3/4 times negative 36 plus b. So I'll get negative 48 is equal to, looks like this cancels and it's a negative or positive 27. It's like positive 27 plus b, 3/4 times positive, oh, it's a positive 36 right here. So this is going to be a negative 27. So now I'm going to add 27 to both sides. And b will be 21. So it means my slope-intercept form, I'll put it over here because I ran out of room, is y equals negative 3/4 x plus 21. Now I didn't have the answer key for that, or at least I didn't have the answer key right, so if anybody sees a mistake in that, definitely let me know and I'll put it in my notes. Now that's the slope-intercept form. Again, if you want the standard form, you're going to multiply everybody. You're going to bring the 3/4 to this side. 3/4 x plus the 1y equals 21. But now you're going to have to multiply everybody out by 4 times, just 4, I think. Yep. Let me just see over here. On both sides, to give us our standard form of 3x plus 4y is equal to 84. It looks like our standard form is. Again, I didn't have an answer key to this, so if there's anything you see wrong, please email me. So that is a notes page. There's only one more notes page, but let me show you what the follow-up with the notes page is, like what the homework based on that one is. So we said our homework is going to be on page, notes are 14, so let's go to 15. So I have to add a couple of things to 15. So you might take a screenshot of this. You don't pause the video. You pause the video. So this question is a little different, but that's fine too. You can figure that out and that out. It just takes it a step further. There's no answer to these right now. These answers go to the new questions I'm asking you. So this is 32 and 33. Don't forget to give slope-intercept form and standard form. Slope-intercept form and standard form. Then add these two more. And these, by the way, these two, their answer is right here. Give the slope-intercept form and the standard form of these. Find the equation of the line connecting negative 2, 3 and 4, 7. Find the equation of the line with the slope of negative 3 going through the point 7, 2. I might have said that fast, but you guys can rewind your video or pause it and write that out. Okay, so that's me giving you notes on 14 and assigning 15. Okay, so the next thing is the next day of notes, the next section of notes, which is on page 16. So if we can all go to page 16, I'm going to pop off and get myself a ruler. I'm still talking. I just need to get myself a ruler. Just going to get myself a straight edge, because I forgot I needed a ruler. Okay, so if I ask you to graph something in slope-intercept form, I'm just going to give you a slope right now off the top of my head, a slope-intercept form equation off the top of my head. So if I wanted to graph y equals negative 2/3 x plus 4, okay? There's a negative here that either could correspond as a negative 2/3 or a 2/3. So you're writing this equation in yourself. So you start by going to the y-intercept, which is 4, and you go 1, 2, 3, 4 on the y-axis. So that's one of your points. Your next point you are going to need is the point. I'm trying to see where my answer is. I wonder where it is. Is either going, so with this negative 2/3, you could go down 2 and to the right 3. That's one thing you could do. So down 2 and then to the right 3, and you land right there. The other thing you could have done is go up 2 and to the left 3 and land right there. But either way, you only need 2 points. This is Norman Rockwell bookmark. I love Norman Rockwell. I just couldn't find a ruler at the last minute. What you should do is always label the y-intercept 0, 4, and then the point that helped you get there. And all you have to do is read that point. And for me, it's 3, 2. You could have written that point too. So you should label, because you will be labeling for me. So if the slope was positive, and it was looking like this, y equals 6x plus 1, you start at the 1 as your y-intercept, and then the 6 is really equal to 6 over 1. So there's your rise, and there's your run, and this is going to be a flatter line, a steeper line, up 1, 2, 3, 4, 5, 6, and then over 1. The further away a slope is from 0, 6 is pretty far away from 0, the steeper the slope. Even -6 would give you a steeper slope. So there's your equation. That's your line. So 0, 1, and then this one looks like 1, 7. And that's how you graph a line in slope-intercept form. You will need to label 2 ordered pairs, and those 2 ordered pairs are the y-intercept and the other point that the slope path takes you to. Let me repeat that in my words. The thing that you're going to label is the y-intercept, that's check it 1, and the other point is wherever the slope takes you and you land on, label that one also. I'm making that very clear, I hope, to everybody. So notice that when you go to do that in tonight's homework, you're not going to have, unfortunately, getting much graph paper. That a lot of the grids broke off on that. I don't know why. By the way, I do want you to know that sometimes you're going to get an equation like, say, 2x plus 3y equals 6. If I want you to graph in slope-intercept form, I want you to isolate like this, and then you have this -2/3 x plus 2. So let's just say it was, So then there's your slope and there's your y-intercept. Because on page 17, it's going to say to take this, to put it in slope-intercept form, to find the slope and the y-intercept, and to graph it. Again, I have no idea why the grids just didn't copy. It's unfortunate. Okay, now can you go backwards and look at the line and say, I'm going to predict the slope and the y-intercept, and then write my equation. This one's easy because the y-intercept is very clear, and the slope is easy, it's counting. So the y-intercept on this one looks like it's 1, 2, 3. So it's going to be y equals something x plus 3. Now here's how we get the slope. We just count to the next point. We went down 1, 2, 3, and we get it across 1, 2, 3. So we went down 3 and across 3. That gives us -1. So there is our equation in slope-intercept form. Now you can't guess this y-intercept here. You can't say, oh, it looks like -3/4. I think I'll put it. You can't guess the y-intercept. So what you have to do is you have to look at the 2 points instead. It looks like the point is 1, 2, 3, 1, 2, 3, 4. So it looks like this point is 3, 4. And it looks like this point is 1, 2, 3, 1, 2, 3, 4, 5. So -3 and 5. So it looks like I don't have the answer here, so we'll do it together. So the 2 points are 3, 4 and -3, 5. Now, you don't have to do the algebra for the slope. All you have to do is count. So you count 1, 2, 3, 4, 5, 6, 7, 8, 9. And then you go across 1, 2, 3, 4, 5, 6. So you went up 9 and then you went across 6. This was a -5, by the way. So 9 over 6, which reduces to 3 over 2. That's your slope. And all I did was do it by counting. I didn't do the arithmetic for it. So I get y equals 3/2 x. Now it looks like it's a minus, so I'm going to write minus, but I'm going to do the work for it over here. So I'm going to do y equals 3/2 x plus b, and I'm going to plug in a 4. I'm going to use this one because it looks easier. equals 3/2. Oh, running out of my pen already. Times 3 plus b. So 4 equals 9/2 plus b. Subtract the 9/2 from both sides. And that is giving you, I believe, 1/2, negative 1/2 for b. So that looks like negative 1/2. And so you write it like this. Okay, now the lesson part that I'm teaching you is done, but what I want to talk to you about is the homework part. So let's be very clear on what the homework is, okay? I haven't asked people to upload yet, but you should be working along so that you do upload when you need to upload if I ask you to. So the homework looks like it's 15, 17, 18, 39, and 40. So I wrote it over here. Video, page 14 and 16, those were all the notes, and I added stuff. The homework is going to get some stuff added to it too. 15, 17, 18, 39, and 40. So let's take a look at page 15 for your homework. I'm adding 2 questions. So here's homework day 2, page 15. This one and this one that have no answer to it. Please put it in slope-intercept form and standard form. And then the answer key to this is these 2 questions that I just forgot to write for you. So here's the 2 points, and over here there's a slope and a point. So write that down. Okay, the next page then is 17. Well, 16 I did with you. 17 is the next page. So what are we doing here that has to go in slope-intercept form? I wish there were grids. It just didn't copy. I have no idea why. And you write the slope, the y-intercept, and then you graph it. Write the equation of the line in slope-intercept form. If you can't read these points, because I do believe they're hard to read, I see them as 8, -4, and 0, -3. Once again, the grids didn't come out. I actually have the grids on my piece of paper. And then don't guess the y-intercept on this one. Make sure you know how to get it through algebra. Okay, the next page then is page 18. And over here, you're going to answer the question about a graph that you see that's a line, and it's in slope-intercept form to answer the hourly charge, and try to use a number in both of these in a complete sentence. Number and a complete sentence when answering that. Okay, now let's look at the SAT stuff you have to do. And this is the last thing I'm telling you. Last thing. So on page 39 of your SATs, notice how they are in a different form. This is in a table of x and f of x. Remember, f of x is just like saying y. So this is just a horizontal table that looks like this. X, y, and it's just giving you the numbers. -4, the order pairs, -4, -4, 0, -1, and 6k. So the k is missing after you write your equation. Mick? Yeah. That's me alerting my son to come do the video and take it off. And again, this over here says f of 1/2 x minus 1. This is just about being a good plugger-inner. We'll get a little bit more to this if this is something you can't do with the function notation. But some people do know function notation, so that's why I'm going to give them this question and some other ones. And then on page 40, I'm taking one of the questions off. Number 11, or number 12 is the one we're not doing yet. We will do that on the next lesson. So just, if you want to try it, go ahead. And so that is your last homework page, page 40. And I'm going to write this all down in Google Classroom.